let V be the vector space of all 2 cross 2 matrices over R. So dimension of this vector space V will be 4 because of in this vector space 2 cross 2 matrices, and we know that number of independent elements in a matrix will be the dimension of that vector space. So 4 will be the dimension of this vector space. Consider two subspace as W1 and W2. If M is the dimension of intersection and N is the dimension of sum of subspaces, then we have to find order pair Mn, where M is the dimension of W1 and M2 is N is the dimension of W2. So consider an element A minus A C D of W1. So at how many position we are independent? If we know the value of A, then minus A we already know. So only we will consider one independent choice in these two, and C and D are independent. So there are 3 independent choices. So dimension of W1 is 3. Similarly, dimension of W2 is also 3. And we know the formula dimension of sum means W1 plus W2, dimension of sum of subspaces, can be written as dimension of W1 plus dimension of W2 minus dimension of intersection. And dimension of intersection, how we can find? If we consider an element of intersection, it means element will follow the rule of W1 and W2. For W1, element in first row, element should be A minus A, and if we follow the rule of W2, first column as A minus A should be, and the fourth element is D. So an element belonging to intersection having this structure, so we have dimension of intersection is 2. So dimension of W1 is 3 plus 3 minus 2 means 4, and some dimension represented by N, and intersection dimension represented by M. So value of M is 2. We have to find order pair Mn. So value will be 2 comma 4. 2 comma 4 is given in option B, so it is the right key.